Let's go back to the restaurant problem with perfect information. This is Guido's knocking at the door with the envelope, and the envelope is perfect. And this is the map we came up with, or the chart we came up with. The payoffs aren't exactly what they were because I keep changing this problem. So let me fix that real quick. And you should somewhere in your direction, in your notes now have the same information. And you should have this tree and that stuff somewhere. Well, sample information is a little bit different. Perhaps you can hire a lobbyist to go gauge the zoning board's opinion. Not to lobby them to change it, different kind of lobbyist, but to figure out what's going on. How much is his report worth? Well, keep in mind, you already think there's a 70% chance that the zoning is going to go through. Therefore, you should expect a 70% chance that the lobbyist report comes back saying, hey, it's favorable. Well, what does that mean? Let's assume that it swings. If it comes back favorable, it swings the probabilities from 70-30 to 80-20. If it comes back negative, it swings the probabilities from 70-30 to 60-40. What does that look like in the tree? Well, I changed things a bit here. So the question is not, do I take the envelope or not take the envelope? So the original problem is still down here. No lobbyist, no envelope, there's the original problem. I do hire the lobbyist. Well, we said there's a 70-30 favorable, unfavorable probability of the outcome. But I don't have the instant decision that I had with perfect information because I still don't know. I still have the decision. What size restaurant am I going to build? I guess just to be consistent, I should label this one with the same question. It doesn't terminate. If I build large, it's still uncertain. So I'm going to delete this. I'm going to use the copy paste abilities again. And copy this. Oops. Oh, that did not work. What did I do wrong? I'm going to paste that on there twice. I still have to decide between a large and small restaurant. The difference is up here. Get these payoffs fixed. If there was a favorable report, we said there's an 80% chance the rezoning goes through. So if I hire the lobbyist, I get a favorable report, I build a large restaurant, now there's another chance event, but the probabilities in that chance event change. If I build a small one, got to get these payments right. I get that. So if I had a favorable report, which I think is a 70% chance it will happen, and I go large, well, I see what happens. There's the probabilities and the payoffs. I get a favorable report and I still build a small, there are the probabilities, there are the payoffs. So it is saying if I get a favorable report, I certainly should build a large restaurant. I'm going to do the same thing down here. I'm going to delete these terminal nodes because it's no longer terminal. This decision, I have the same two decisions, leads to another chance encounter. So I can, again, build a large or a small restaurant. Now the probabilities change. instead of being 80-20, remember now if this is the negative, this is the negative lobby report, we said it's going to slide the probabilities the other way to a 60-40 probability. So I got the 60-40, I got the first payoffs, I have to fix these last payoffs. Right now it's saying it makes no difference because it makes no difference. So be careful that you don't finish, or you do finish, I should say, be careful that you do finish your diagrams. So it's a much more complicated tree. As small as you can see the whole thing. I'll blow it back up, and this tree will be also on Schoology. So sample information is more complicated. Remember, the original problem was literally just this piece of the tree down here. Guido's perfect envelope changed the problem to this. If it's not perfect, it's sample information, then my decision still leads, because I still don't know. I only have an indicator of favorable or unfavorable that will change the probabilities out here. But it still leads then to a decision that leads to, we don't know what's going to happen in the future. It's interesting, it does say you should go ahead and lobby if this is true, because lobbying will have a $39,300 expected value against your original expected value, which I need to fix these numbers again. Original expected value of 35.5, it's 39.3. Not nearly as nice as the 47.5 expected value that we had for perfect information, but in this case, if the sample information could spin it or shift things by 10%, 80-20 or 60-40 instead of 70-30, then the information is worth 39.3. So the value, the difference, is a little less than $4,000. So if you can get the lobbyist to do this for $1,000, for $2,000, it's worth hiring the lobbyist. If he wants $5,000, it's not worth hiring him. So this is a useful process, but it does make a more complicated tree. And it tells you what to do. Kind of, here you guessed. Notice if you went down here, you would just build the large on the expected value. But here it says, if it comes back unfavorable, now the risk is too high. Go ahead and build the small restaurant. If it comes back favorable, go for the big restaurant. So, in terms of where we are here, we did those two, and I'm going to throw some other problems at you, have you kind of do them on your own, and then I'll show you the solutions. So we're going to take another pause.